Alright guys, well today I'm going to be talking about the human brain, and kind of a little funny fact depending on it, the way you look at it. The human brain is the only thing really in existence that actually named itself. Well, I'm going to first start with some of the major structures that we see in the brain. First off, it's the brain stem. Okay, this helps keep your balance, homeostasis, kind of helps you also keep moving, but it's also important because it helps move data throughout the brain centers. Second is the medulla oblongata, which helps control your breathing, your circulation, swallowing, digestion, kind of some of the more important aspects in everyday life. The pons also controls the breathing. And the midbrain helps receive the data from other areas. It integrates the auditory, so what you hear. It also helps coordinate your visual reflexes, so like how you react to something visually. And then it also helps send sensory data to the higher brain centers. Now, secondly, there is also the cerebellum, which, similar to earlier, it helps coordinate your body movement and also plays a pretty large role in learning and remembering motor functions. So when you're, like, say, playing baseball or playing football, whenever you're constantly doing a certain movement, your cerebellum is going to be one of the important areas to help you remember that movement, such as throwing a fastball. Next is the thalamus. The thalamus is kind of an input center. It's where all the data goes right before, well, sensory data goes right before it goes to the cerebellum. The hypothalamus helps function as a homeostatic control center. It controls the pituitary glands and serves kind of as your dietary clock. And then finally, the cerebrum, which I'm sure everyone has heard of because it's probably the most famous part of your brain. It has a lot to do with your memory, learning, speech, emotions, behavioral responses. It's kind of like anything you learn to do, learn to react, your speech patterns, how you're going to react to something, how you're going to feel about something. All of this comes into play in the cerebrum. So, as you can imagine, it's a very important part of your brain. Next, we just have a quick little photo of where everything is located. You can see the cerebrum up top, the pons right above the medulla, the thalamus in the middle, and the cerebellum at the bottom. Now, one of the important aspects of the human brain is actually its capability for neurological rewiring. Now, the term for that is neuronal plasticity, which is its capacity to be rewired. So, while we say rewiring, it doesn't always mean that. It's kind of the wiring between the neurons. So, what we see this most commonly is when you're learning a new subject or even trying to master a subject. So the neurons are constantly sending signals, and as they send out more and more, they'll join more together. Kind of like how if you play the piano daily, how you start to learn it and understand a lot better. More and more neurons are then used to try and record the information that's receiving. Now, this is also extremely helpful in regards to brain injuries. So, we'll sometimes see damage in neurons that can be fixed from repeated head trauma, such as, playing football. Now, the nice thing about this is, since our body is capable of it, instead of just every time we get hit in the head, we forget and we forget and we forget. Instead, our body kind of self-corrects itself to keep working and keep relearning to make sure we don't forget everything. Next is the limbic system, which is kind of one of the most important aspects of the brain, actually. See, the limbic system is heavily involved with memory. The hippocampus, which is involved in the formation of your memories and how you recollect them. The Amygdala is where most of your emotional memories are contained. So while the hippocampus helps create the memories, and when it's highly emotional or involves a lot of emotion, it goes to the amygdala central. Okay, so there's two forms of memory generally that we all have. There's short-term memory, which would be you look at a piece of paper with a telephone, number on it. So you sit there, you repeat it over and over, and then you input the telephone number and you forget. That's it. That's it for the telephone number. And long-term memory, well, one example would be riding a bike. No matter how old you are, you never truly forget it. But going back to the telephone number, it's when you memorize that telephone number and put it, but then you still remember it for, days, weeks, months later. Now for some neurological disorders, which I found to be one of the more interesting parts of this chapter. So starting off with is schizophrenia. Schizophrenia occurs in about 1% of the total population of the world. And when I give the percentage from here out, it's going to be of the world. Symptoms will actually include hallucinations, delusions, blunted emotions, distractibility, lack of initiative, and difficulty with verbal expression. See, all of these, though, currently have no true cure, by the way. Secondly is bipolar disorder, which actually affects around 2.5% of people. It is characterized by extreme mood swings. When things are good, they are marked by high self-esteem, increased energy, and flow of ideas. Extreme risk-taking and promiscuity in some cases. When things are at their low point, there's less ability to feel pleasure, loss of motivation, sleep disturbances. Sad thing is, this comes with a pretty high risk of suicide, especially in those that they're not taking any medication to try and manage it. So the other part, there are 4 other disorders, which are Alzheimer's, Parkinson's, CTE, and stroke. In the case of Parkinson's and CTEs, we do have a rather good idea of the causes. Generally, in regards to CTE, it's by repeated head trauma. We mostly see this in fighters, football players, and like. Parkinson's, we're not sure, but we believe it involves the loss of dopamine levels in the brain. Alzheimer's is more frequent now as people get older and older, and as the baby boomers get to 65 and up, it's just going to skyrocket. But we have no true knowledge of what causes it. And then here is my works cited. All right, thank you.